Welcome for this talk on demystifying MLOps, propelling models from prototype to production, presented by Ashmi Banerjee. So, Ashmi is a full time data scientist. Um, Ashmi, can you please help me with the name of the company?
It's Deutsche Telekom or German Telekom, basically.
Okay, German Telekom, and a self taught web developer. She has a master's degree with a focus on machine learning and artificial intelligence in computer science, informatics, from Technical University of Munich, Germany. She gets excited about new technical challenges and automating mundane activities using technology. As a Google Woman Techmaker ambassador and a diversity enthusiast, she is passionate about bridging the gender gap in STEM through a myriad of voluntary activities with a different women in STEM networks like Female Tech Leaders, Women Who Code, and Women in CS at TUN. Also in Anita Borg's Indian Women in Computing, etc. And when not sitting in front of a computer, she's either traveling or training to be a triathlete. So that's awesome, Ashmi. If you are all set for your talk, you may continue later.
So thank you so much, Pujita, for the introduction. And yeah, so as Pujita introduced, I will be discussing with you today about demystifying MLOps. Don't stress, I will tell you everything, what they are and how it works and everything else. So yeah, so if you are ready, then maybe we can begin. First, I'll walk you through the agenda, what we have planned today. And so first I'll introduce you what MLOps and why do we need it. So we start with a brief overview of MLOps, what it means and why do we need it, what is the motivation behind it, what happens if we don't use it, and so on. Followed by we'll talk about MLOps workflow and how it is different from a traditional machine learning workflow. So, and we'll also talk about a bit about the pros and cons of both. And then we will talk about the much talked about topic of DevOps and MLOps and what their differences and what their similarities are. And then we talk a bit about the role of an MLOps engineer and their responsibilities and the kind of expertise and the skill set required to be an MLOps engineer. Last but not the least, we will talk about the different MLOps infrastructures that are available, along with their pros and cons. So if you are ready, then we shall begin. First is what is MLOps and why do we need it? So according to the actual definition, MLOps is a set of best engineering practices in machine learning, software engineering, DevOps, which is like a superset of DevOps. So DevOps is basically a subset of software engineering and data engineering that basically helps you build efficient and reliable systems in production. So I will just, for once, I'll focus on the theory part now, and I'll tell you the actual motivation with the help of a story in a second and why we need it. So basically, as the name suggests, MLOps is machine learning operations, which is a combination of machine learning, obviously, followed by data engineering and DevOps. So, and it's in the intersection of all three of these, as the Venn diagram on the left shows. Next, why MLOps? First of all, this is not me. I guess you have noticed that already. And it's just a picture from Unsplash for representational purposes. In this part, I will talk about a personal experience, a story, and then hopefully you will understand the need of MLOps. So this dates back to some time ago when I accepted the offer as a data scientist in a German company. I had joined a team of about 4 or 5 other data scientists who have been working on interesting data science related problems for the last couple of years. I was very excited. Data science, yay, I get to do data science. And one of my tasks there basically, so I got multiple projects, and in one of the projects, the task was to fix some bug in some data visualization thing. So they had some issues, like something was visualized in some way that it was not supposed to be visualized that way. So there was some error in the data, and this thing was happening in production on the client side. And the colleague who had built this system was no longer in the company. So I was taking over their responsibilities. So I was very surprised because the first thing I realized there was no documentation for any of the things that were done. So surprise, surprise. And just a sec. Yeah. And not only just that, there was no there was like everything, all the code was written in a single huge Jupyter notebook, which took forever to load. So basically it was like a complete mess. And finally, the whole, like, there was no concept of using functions or modularity or anything in the code. It was just like one huge chunk of code where everything was written. And yeah, and there was, the most important thing was there was no version controlling available. So it was next to impossible for me to reproduce the bug locally for debugging purposes. And needless to say that I had a great time following up on the colleagues' work and had to start everything from scratch. As I tell this story, I'm sure a lot of you can already relate to at least some parts of it to some extent. And this is exactly the reason why we need MLOps. This is because MLOps provides a more structured way to manage your ML projects or your data science projects. Now, let's look into the actual things. This is because when you are developing a prototype, you are developing your models for prototyping in on your computer, on your local machine, in a single Jupyter notebook, and that's perfectly fine. But then you want to deploy this thing in the production. Problem begins, because most of the things will fail there. You will encounter a lot of situations when things will not be as expected in the production. Because if you have not had a very systematic and organized way of deploying your models, or organized way of development throughout the process, then it's very likely that your models will perform well, or your models will not break in production. Very unlikely, I'm sorry. Yeah, that your models will not break in production. The next thing is that this whole process, if you do it manually, because what happened in this example that I cited was everything until the deployment, until the end was done manually. So if you have to fix some things, you have to repeat all the steps after that step manually, or you have to start from the scratch and then do it everything on your own. So that's like tremendous amount of work, and it's not flexible at all. The third thing was it was not scalable, because you are like, a Jupyter notebook is definitely not scalable, or anything that is developed without any structure, without any without any structure is definitely not scalable. And obviously it will break in production. So, and also if it breaks in the production multiple times, you are losing on a lot of costs, you're losing a lot of money. This is because your system is down for a certain period. You have downtimes, you have other resources and stuff, resource consumption is high and stuff. So obviously if you have MLOps, if you have a structured way and a structured set of engineering practices which you can follow, which can guide you through this from building your models like locally until you deploy them into production, then obviously you save on a lot of costs. So now let's look into or try to understand how an MLOps workflow works and how it differs from the traditional one. So first, a traditional ML workflow. There you have a training. So obviously a training phase. So you have the data and then you are training the data and then you are doing the validation and then you're testing it. So very simple. But the problem with such a model is the following. There's no model retraining occurring here. So that means there is a chance of model decay, which means that since there's no model retraining, so basically the model has been trained on a fixed set of data once, whatever, like a lifetime ago, and then it has not been touched anymore after that. And so the model is now very much prone to model decay because it's not performing that well for new data. And if you have a varied amounts of data and also in like different types and quantity, obviously model has not seen all these things and it's new for the models, and obviously it ends up in problems or like it ends up generating erroneous results. Next. This is good for prototyping, but definitely not suitable for production because of the reasons I mentioned before, that this thing is definitely not suited for production because you cannot deploy a Jupyter notebook in production. I mean, you definitely can, but it will probably break, like I mentioned. It's not efficient. And I mean, yeah. So, and then you have the manual process of deployment, as I mentioned, that it's not a scalable process. This is because everything has to be done manually and there is little to no automation. Last but not the least, your model breaks in production. Surprise, surprise. Hence, we introduce the MLOps workflow, where hopefully, if everything goes well, then you can end up building an automated, scalable, robust, and system where the models do not break in production. So here, first, we need to have a good business understanding of the problem in hand, followed by the usual data storage, cleaning, and training activities. They have some subsections which include like data acquisition and then the ML modeling and finally training, validation, testing, all these things. So you keep doing it in a loop until you are happy with the models that you have and the results you have. And then you start the continuous operations phase, which includes the continuous integration, delivery, training, and monitoring. So I'll just quickly tell you what each of these things means because they are the center or they're the main parts of MLOps. And this is exactly where the whole automation thing that I have been talking about begins. So continuous integration is that you build a part of your project. So you work on a part of your project and then you would like to integrate it with the entire big project. And it needs to fit, right? So therefore, you need to write your code, you need to prepare that in a way that it fits with the existing models. Next, we have continuous delivery so that you can already deploy it in production, followed by continuous training, as I said, because to avoid model decay, we need to retrain our thing in repeated interval in some cases. And continuous monitoring, because once the model has been deployed, it's important for us to keep an eye on the model's performance to see that it's performing as expected and there are no surprises. Because in case there is something, then it's also our job to fix it. Next comes the production. So once you have this continuous operations things automated, then finally you can go into production where you are deploying stuff, and then you have your KPIs to measure the performances. And then you also have some explainable AI part where you try to understand the working of the model, like why is it behaving the way it is behaving and why is it not behaving the way it should be behaving, or all these things. And followed by sustainability, because all of these things, these models, deploying them, training them, retraining them, all of these things involve a lot of carbon footprint. So, and in turn, they may or may not be always very sustainable. So maybe it's also worthwhile to take a look at the sustainability aspects of your models or aspects of your whole project to see that you have the minimal carbon footprint for the same. The advantages of such a thing is that automated operations and deployments, followed by a scalable system. So you can scale up and scale down according to your loads and needs very fast. And you have continuous training, so therefore you can avoid model decay now. And it's a robust system which means that hopefully when you deploy it in production, it will work as expected. So now the main difference between MLOps and DevOps. First, the similarities. So MLOps is a paradigm which is derived from DevOps. So there was DevOps first, and then MLOps. The ML enthusiasts, they decided to follow a similar approach for ML projects, because there are lots of parts like the continuous integration, continuous delivery, and continuous testing, and all these things. These are very, very similar to the traditional software engineering DevOps approaches. And hence, so the similarity with MLOps lies there. How MLOps differs from DevOps. MLOps is definitely much more experimental in nature, because data scientists always need to tweak a variety of parameters, models, hyperparameters, etc., all at the same time, and then code versioning, etc., to ensure the robustness and reproducibility of the results. Followed by the interdisciplinary team formation, because a regular ML team comprises of ML researchers, data scientists, researchers and data scientists, but an ML ops team is basically a combination of all of them, as I mentioned before, that data scientists, data engineers, software engineers, DevOps experts, everyone. It always Next is model testing. So it also involves model testing, which is in addition to the conventional unit tests and integration tests and performance tests, you also need some sort of model testing to test your models to see the way it's been performing, including model validation and retraining. And then you would need automated deployments, because as I mentioned before, that to prevent a model from being redundant or being absorbed in model decay, we need to have the things automated so that you can automatically train it on new data. And last but not the least is model monitoring, which means that the statistics of how the model is performing needs to be observed. Now, the role of an MLOps engineer and how it differs. So, as you can already guess, that we are looking for a person who has cross-functional expertise when we talk about MLOps, because they need to have the knowledge from all three areas. So machine learning, data engineering, DevOps. And their job includes building and maintaining all the ML infrastructures, the workflow orchestrations, and the monitoring of all the things, and from setting up the whole system to until monitoring it, everything is included in the job of an MLOps engineer. In the next slides, I will show you the ML workflow, the MLOps workflow, and how the responsibilities are divided between the different roles. So if you have the experimentation phase, which belongs to the data scientist or ML engineering, the next phase of continuous testing belongs to ML engineering as well, and a data scientist, followed by a model deployment, which is ML engineering and DevOps. And lastly, it's continuous monitoring, which is ML engineering and DevOps again. So basically, the first two parts are data scientists and ML engineers, and the last two parts are ML engineers and DevOps engineers. And hence, together, you have your whole ML ops. Now, the technical skill set for software development, I'll quickly go through these things. I'll not read out from the things because they are pretty obvious. So as I mentioned, that you would need software engineering, software development knowledge. You would also need DevOps knowledge, so Docker, Kubernetes, etc., and other orchestration tools. So these are just examples of some technologies that I have listed here, but they are not all. So, and also you're not required to be an expert in all of them. So what is required, and then you would need some knowledge in cloud infrastructure, like the usual public cloud infrastructures like AWS, Google Cloud, Azure, etc. So again, don't get freaked out because you are not required to have expert knowledge or expertise in all of these things, but it's just like good to have. It's a whole set of stuff. So it's not like everything you need to be a tech guru expert in all of these things. No, if you're an AWS expert, good. You probably can pick up the others as well. So it's only the concepts, only the knowledge that matters, and also the willingness to learn. And you would need some MLOps frameworks as well, like MLflow, Kubeflow, and Airflow. So these are just examples. Obviously, they are not the exhaustive list. Among the non-technical skill sets, obviously, you need a lot of communication skills because it's an indispensable skill for any developer because you need to communicate between the business and you also have to communicate with the data scientists because of the kind of requirements you would have. You need to have good problem-solving abilities because you are solving real-life problems. And finally, you need to be a good team person because you're working with an interdisciplinary team of people. And if you don't have good people skills, then it's a problem. So now I will introduce you to the different MLOps infrastructures. So the solutions for MLOps or implementing MLOps in the industry that are available, along with their pros and cons. The first is, or one of the most common solutions is the end-to-end solution where you have like cloud services, managed cloud services like Azure, Amazon SageMaker, Google Cloud, etc., that provide you an end-to-end service. So the advantage of this thing, so the green things highlight the advantages, and you will see in a second that the red things highlight the disadvantages of each of these infrastructures. So it's a fully managed and a commercially available infrastructure, which is very easy to build, scale, and automate because they are thoroughly tested. So they are also like reliable. However, they can be expensive because you don't know how much you have to pay and depending on your projects and stuff. And it does not work well when you're handling like sensitive data which cannot leave the premises of your company. And then if you're using a third-party infrastructure, then it becomes tricky. The next one is a custom build, which means that you can use any of, you can use different technologies to build your own solution. For example, Airflow, Kubeflow, MLflow, these are some of the most widely available ones. And this offers a very robust solution for your projects because you are building each of the blocks together. So you have full autonomy there. Next, it's also very flexible because again, you are building them as independent microservices. So if something fails or if something is not working, you can fix it on your own, or as I mentioned, you have the flexibility or the full autonomy to build it however the way you want to and in whatever the way you want to. And However, the downside of such a model is that it requires expertise. So often it requires you to hire people with certain expertise in certain technologies and expert people who have an overview or who have an in-depth understanding of the available technologies, and then they can, weigh out the pros and cons of different things. And last but not the least, it also has an increased process complexity because it's making things a bit more complex because things are scattered into different microservices and they are like communicating between each other or among each other, and then obviously it boosts up the process complexity. The last but not the least is the hybrid model. So which is a combination of some on-premise infrastructure followed by the end and cloud infrastructure, so like a fully managed one. So in that, what happens is that it is an ideal situation when, say, the company is dealing with some sensitive data which cannot leave the company premises. So in that case, it houses that in the on-premise infrastructure, and for the rest, you have the existing commercial cloud infrastructure. So this way, they can avoid the data, and they can also have the flexibility or the advantage that they can have a fully managed, fully tested, reliable system to handle the rest of the operations. Definitely cost saving because you have a part which is in-house, so you save a lot of cost there. However, it adds an additional layer of complexity to your system because you have to build a system in-house and then integrate it with some existing system and then build it around it. And then you have the issues of security, privacy, availability, stability, and all these things because you're adding an additional layer and you're integrating two different systems and you're building something from scratch. So I guess you are all software enthusiasts or software developers, so you know what I'm talking about. The most important question here comes now is the fact that I have these three kinds of infrastructures, but which one should I choose? And the answer to this is very simple. Look for your project, see what requirements you have, look for your budget, see again what you have there, and look for your expertise. If you know the answer to all these three questions, you know which one to go for. I will quickly highlight some popular MLOps tools so that you know where to start from if you're looking into this area, and before concluding my presentation. So some popular MLOps tools for data versioning could be DBCs and Dolt and Data Lake, followed by some for experiment tracking. You can use TensorBoard. So the Google fans, you can use TensorBoard, and then you have like ModelDB. And for model deployment, you can use again TensorFlow, PyTorch, Kubeflow, etc. And finally, for ML, so TensorFlow serving, by the way. And for ML lifecycle tools, you have the usual cloud providers or the cloud interfaces like Amazon SageMaker, Google Cloud, MLflow, etc. With this, I actually come to the end of my presentation, and I would like to do a quick recap so that you have all the main takeaways with you. So MLOps is very simple, ML plus operations. It involves continuous and automated operation process, so it helps to automate certain parts of the whole pipeline so that we have a more flexible and efficient system in production. And there are different types of MLOps infrastructures, and depending on your need, your requirement, budget, and expertise, you choose the kind of infrastructure that is suitable for you. With this, I come to the end of my presentation. I have collected all the resources that I have used for this presentation under this link or this QR code. So feel free to look at that. And yeah, I'm now looking forward to your questions. Thank you very much.
Thank you so much, Ashmi. This was a wonderful presentation. I really enjoyed it, and so did our attendees. We have a few questions. So, someone is asking that as a junior data scientist, that you have been mostly working with models locally, do you have courses or books recommendations to start learning the basics of MLOps?
Mm-hmm. Yes, I do. I personally took up the course, the MLOps specialization on Coursera. I would highly recommend that. I feel like it covers all the essential aspects, and it's also a good start for beginners.
Awesome. So I think attendees might have taken the note of it, and if not, I'm going to repost it in the chat. So it was MLOps on Coursera.
Mm-hmm.
Is there
Exactly.
any organization specific which
I
provided this
think,
course?
yeah, I think it's Andrew Ng, but just give me a second. I will just double check before saying that live.
Yeah,
Um,
that's
yeah,
great.
it's by Deep Learning AI. So Andrew Ng, yeah,
Okay.
deeplearning.ai.
Mhm. Okay, so I've posted it in the chat. So there's one another question. So someone is asking that in a company like German Telekom, how the MLOps slash DevOps boundaries are being managed for data scientists, data engineers, and software engineers. So, from
Mhm,
personal experience, small teams of data science often resource to their own end to end toolings, such as GitLab and cloud platform, while the central IT department are running behind with suitable options with rigid installations.
mhm.
Anything you'd like
Yeah,
to?
I think that's already answers a part of my part of the question that was asked. So basically, what happens is that depending on the kind of project you're working on, the confidentiality of the project, and also the teams that you're working on, they are using different infrastructures and they are using different types of technologies to do stuff. So some say, for example, if you're working in a research team who are working mostly on like building prototypes, obviously they are not producing stuff in production. So they are working on local things like Jupyter notebooks and the usual Python and like that. But however, if you're working in a team which is deploying stuff in production, they are a bit more advanced. And depending again on the kind of data that you're using, the kind of projects that they're using, they are using the different solutions. Could be their own in-house solution, or they are using some like managed devices, managed services, etc.
Okay, thank you so much for sharing. Also, one of the attendee has written that first of all, thank you. And I recently saw a list of tools designated as data science platform. Here's the so they have mentioned some few of them. So few are Databricks, Coiled, Data Robot, and Domino, etc. So have you used any of these previously? So they want to know that.
Mm-hmm. I personally have not used it. I am actually also a beginner in this area, so I am starting my MLOps career or the ops part of MLOps career now. So I have worked in ML parts before, but I haven't worked in the ops, as I said. So I haven't used these tools in particular. Right now, I'm mostly focusing on learning like specific technologies, which may be interesting or which may be useful if I would like to develop a whole pipeline or a big project. So
Okay,
personally, yeah, I would say no.
okay, that's awesome.
Mhm.
Um, there's someone asking that do you have any tips on how to keep up with the new tech coming up in this area? So since you are trying to get into a new field yourself, so I think you'll be able to answer this question very well.
Yeah, I would say for me personally, what helps is social media. So I try to follow the people who are working in these areas or connect with them over LinkedIn or Twitter, and then try to see like what they're doing. And obviously, I mean, the social media now uses such advanced algorithms that if you follow a few people in this area, then you start getting, relevant information or relevant posts from them. So that way it kind of helps. And yeah, so I would say keep an eye out for all these things. Also, you can check out like if you're interested in research, actually like tech research and like the kind of problems that are being tackled by those communities, then you can keep an eye out for like the top tier conferences and their like the conference proceedings, and see what or are how they are publishing new results and what they are like if you find something interesting there.
Yeah, I think those all suggestions are really great. And I would just like to add one thing that, platforms like Women Who Code itself is a great way, to connect
Exactly.
with people. Join our Slack channel and you'll have like abundance of people who are working in different techs and are from different backgrounds, and you can, chat with them, connect with them, know how they started learning that a particular resource and stuff like that. So I think communities like this really support us to get into a new field and also get some hands-on experience. So yeah,
Absolutely.
I would like everyone who has not yet joined our Slack channel to join it, and you can, connect with people there. That's a really amazing resource. Also, LinkedIn, I know, is such a great, as Ashmi mentioned. That's a great way to
Mm-hmm.
connect with people.
Mm-hmm.
Yeah, so that's great. Um, someone is asking that can you give the link of your slides? I think this QR
Yes.
code is for the slides only, right?
No, the QR code is for the resources, but I think as someone also mentioned that where he mentioned that they are on my website. So I will actually put it on the GitHub gist as well after the
Okay,
talk. Yeah.
awesome. So people can, use this QR code to go to the GitHub, and there she will post the link for the slides. That's awesome.
Yes.
We still have some more time remaining, about 5 minutes. And so I would like if anyone wants to ask Ashmi any other question or any other tips, please feel free to drop it in the chat.
Mm-hmm. Yes.
So by the time our attendees, drop their question. Okay, so we have one more question. So Ashmi, it is that which is more interesting to you, ML or MLOps?
I would say right now I'm enjoying MLOps because I'm learning something new and from scratch. So that's quite interesting. But ML is also nice, and it depends on the problem actually. It's not a specific technology. For me, it's very important to work on uh, interesting projects or the problems which I am passionate about. So it's the problem in hand that matters more than the technology for me.
Yeah, that's a great advice, to people to follow as well. That solving a problem is more important than how we solve it. So yeah,
Exactly.
learning.
I mean, maybe one more addition to this thing. I mean, obviously, I'm not encouraging you to use some like super backdated, like, I'm not encouraging you to write your code in Fortran or something like that. But like, so technology there matters as well. But I'm just saying that, if you have like five different cutting edge technologies or like latest technologies on your plate, then which are equally good, then probably like I would try to solve it with the one that I'm most comfortable with at the moment. And yeah, before going into the.
That's great. So Ashmi, I think few of the attendees are not able to scan the QR code, maybe due to some reasons. Can
Okay.
you also post the link of GitHub if
Yes.
possible?
Yes.
Okay.
Just give me a minute. I will post it. Mhm. Uh, okay. Mhm. Yep. I shared it. I hope it works.
Let me just check. Yep, it works fine. Thank you so much for
Okay,
posting it. Also,
you're
we have got
welcome.
another question.
Mhm.
What would adopting a microservices and functional modular approach help? So, in your experience, does
Yes,
it
of
help?
course. I mean, that make things a lot more easier from one respect. So from debugging and problem solving perspective, it's much easier if you have if you have like microservices connected to each other. But then obviously it increases the complexity of the same. So it depends again on what your requirements are, which problem are you trying to solve, and what your budget is, what kind of expertise you have. So I identified these three main factors when deciding what kind of project I need to use or what kind of technologies I need, not project, but what kind of technologies I need to use for my project.
That's great. We have another, question. They are saying that I saw that you have a bike tracking project. Can you tell us more about that and why you started that? So, if you are comfortable sharing your project.
Yes and no. So I am doing this as a part of my private engagements, and this project was a part of my work thing. So like it was both a private and work thing. So I'm not sure I'm fully comfortable in sharing all details here. But just to break the suspense, yes, I did start something together with three other colleagues at work. Our goal was to found like a sustainable, energy efficient, and low cost bike tracking solution. Using some technologies that are developed by our company, and it's still in its prototyping phase because right now we had a bit of shift in priorities and like some other organizational problems. So yeah, it's a bit stalled at the moment.
Okay. Thank you so much for sharing all that with us. We have about a minute left. So, any last minute questions for Ashmi? So, someone is asking, do you have an example about how it looks like the automated retraining process?
So the automated retraining process would be something like you have, obviously if you have different microservices, and then that's why it's easier to develop the whole thing as microservices. And then if you have the automatic retraining, so then you have new data and then you feed it to your model, and then the model it trains while you have different model versions in the repository, like the model repository. So basically your system doesn't suffer a downtime because it's still being uh, it's still working on a previous version while you are using the like you're using fresh data to train your model in the new version. And then once you have the new version ready, you deploy it, and so now your whole system is being it's working on the new version. I
Okay.
hope I could explain it well.
You explained it really well. So, I think we are about time. So, thank you so much, Ashmi, for presenting today.
Thank
And thank you
you.
so much, all, for joining for the talk.